Okay, good evening everyone. We are going to be doing the Chapter 2 review. So, I'm not doing like all of it, I'm just doing a couple problems. Trying to set up each one. So, what we're going to start off with is the first page. Got some problems front and back. Now, there are three types of angle relationships on these, and you just need to identify them, plug them in, solve for the angle. It says find the value of x and then solve for the given angles. That's not entirely accurate. So here we go. We start off, we have our three angles. We have vertical angles, which those are the x angles or the bow tie angles. Because they look like a little man, they look like a little man wearing a bow tie. So you have A and B right there, okay? And the vertical angle theorem says the vertical angles are congruent. So the measure of angle A is equal to the measure of angle B. The second type of angles we have are supplementary angles. And supplementary angles, in this case, they're all going to be linear pairs, okay? So they're going to be linear pairs. So they're supplementary. And we have A and B right there. And if the measure of A plus the measure of B equals 180. So if they're linear pairs, they add up to 180. Finally, we have complementary angles, and those are two angles which add up to 90 degrees. So on these ones, you'll see that there's a reference to a right angle, and the two given angles A and B add together to make that right angle. So let's show an example of each one. So if we look at number one, it's a bow tie angle. So they're vertical angles. We look up there and say, hey, they're equal to each other. So we're just going to go 73 equals B. So and that's it. We're done, right? Because we know B equals 73 and B identifies that angle. So let's look at number two. Those are supplementary angles. Some people get confused by that extra line. But we're going to go B plus 62 equals 180. Subtract 62 from both sides, and we get B equals 118. Number 7, we have complementary angles. We know they add up to 90, so we have 40 plus B equals 90, or B equals 50. See? That's it. Now, all of these, the rest of them, they'll either look like number 1, number 2, or number 7. Doesn't mean they're going to be identical. It just means that they're going to have, if you write down, they're going to have that basic shape. If you write down what I wrote up at the top of this page, right there, the vertical angles, the supplementary angles, the complementary angles, what they look like, and you have that down for your test, should be good to go. Okay, so here we have then the second one, and this is all the logic stuff, and this is where it gets tough. So we're going to start off with a counterexample. For a counterexample, what we want to do is we want to say that this part right here is true. It is an apple. Okay, so our statement is an apple is a red. So to prove that false, what we need to do is say, hey, when is an apple not a red fruit? Not when is a red fruit an apple or when is a red fruit not an apple. But we assume the apple part to be true. And we want to, so in the second one, it would be the if a parallelogram has 4 congruent sides. So our hypothesis, our if part, our statement is true, and then the back end is false. Okay? So an apple, when is an apple not a red fruit? Well, when it's a green apple. When it's a green fruit. Okay? Or a yellow one or whatever. If a parallelogram has 4 congruent sides, then it's square. When is that not true? Well, when you have a diamond, or the technical term is a rhombus. Okay? So we took the first part as true, and then made the second part false. Okay, so for 5 and 6, and for any of these type of problems, these are called conditionals. Any conditional has a hypothesis. That's the if part of the statement, because that's all a conditional is an if-then statement. We have the hypothesis, or P in logic shorthand, and then we have the conclusion, or Q in logic shorthand. So we're going to have, so the conditional is P, if P then Q. Okay? So the converse, we're just going to switch that around. We're going to say if Q then P, or if blue then red. So what we're going to do is we're going to write the conclusion first. If a polygon has exactly 3 sides, and then we write the hypothesis, then it is a triangle. See how all I did was switch the hypothesis and the triangle, switch the red and the blue, the P and the Q. So an inverse is negative P, then negative Q. If negative P. So what we're going to do here is we're going to write the exact same one as our conditional. If it's a polygon, if the polygon is a triangle, then it has exactly 3 sides. And instead, what we're going to do is we're going to we're just going to negate it. So if a polygon is not a triangle, so if a polygon isn't a triangle, then it doesn't have exactly 3 sides. See, we took our initial statement and just put 2 no's in it. The contrapositive, again, other than being the funnest word to say in geometry, is if not Q, then not P. So we go, if a polygon doesn't have exactly 3 sides, that's the if not Q. The Q's our conclusion. So we go, if the conclusion is it has exactly 3 sides, the negation of that would be it doesn't have exactly 3 sides. Then it isn't a triangle. Okay? So repeat that for number 6. Oh, we need to say whether or not they're true or false. All of them are true. So moving on. Okay, so I know a lot of this is tough for people. So if I go over something and you don't get it the first time, go back, watch it again. Okay? Watch it a couple times, then try and do it on your own. Put the video away, work through it, see what you can do. Then if you get stuck, come back, watch the video. Okay? If you're having trouble on a problem I don't go over, drop me an email. It's okay. But make sure you know how to do this stuff. The only way people get better at things is practice. You can't just sit there, expect to look at it the first time, or do one thing of homework and know how to do it. You guys gotta practice, okay? That means working through it, fighting through the boredom, through the frustration, and just getting it done. So, next we have, is each statement a good definition? A good definition is when you have a true conditional and a true converse. You'll also hear me refer to it as a true biconditional. Okay? So what we're going to do is we're going to write each of these statements out as a converse or as a conditional, an if-then statement. See if that's true. If that's true, then we're going to flip it around and look at the converse of that statement. See if that's true, and if both of those are true, then we know it's a good definition. So for the first one, it says a square has exactly 4 right angles, which is true, okay? So we're going to say if it's a square, then it has exactly 4 right angles. And that's true. The problem with this is if I flip it around and say if it has exactly 4 right angles, then it's a square. And that's false because they're rectangles, okay? So we say no because it has a false converse. Okay, so that's not a good example. Remember, a good example has to not only go from the word to the definition, but also the definition to the word. Okay, so it needs to be able to say, hey, listen, not only does a square describe something that has 4 right angles, it's true, but the description of 4 right angles applies only to a square, and that's not true. Okay, so for these ones, have your sheet out, okay? Have your list of properties out. Because while I do this for a living and I do this numerous times a day, I've memorized the properties. I don't expect you guys to, okay? So for number 14, we're going to look at this, and we look down and we see that it's the symmetric property. The symmetric property in your notes should say, if A equals B, then B equals A. And that's basically the same thing we have here. We have if, oops, nope. We have if the measure of ABC equals the measure of DEF, then we can flip it around. The measure of DEF equals the measure of ABC. And that is the symmetric property. So now we're going to look at number 16. Number 16, we're looking, hey, what's the difference between this, x plus 7 equals 5, and the back end? And that is those two negative 7s. Now, I know we don't write it this way when we're doing working class, but if you look at the problem, you see, hey, listen, the only thing that changed was they put a negative 7 on both sides of the equation. And so we have to ask ourselves, we go, hey, self, I'm like, hey, what's up? And we go, self. So I was working on this problem, and then self starts drifting off, so you got to hurry it up. I'm like, okay, self. So what changed? Or what allows us to subtract the same thing from both sides of an equation? And self says, well, it's the subtraction property of equality. Okay? And then on number 18, we have A is congruent to itself. And that is when you tag something as congruent to itself, that's the reflexive property. Here it's going to be the reflexive property of congruence. If it was the measure of angle A equals the measure of angle A, we would say it's the reflexive property of equality. But where it's only, where it's congruence, not only congruence, where it's congruence, we're going to say the reflexive property of congruence. Okay, number 20, we're doing evens right now. Number 20, we need to look at that relationship and go, okay, what is this relationship? The three relationships we worked with were vertical angles. Are those vertical angles? Good job. I want to sit there like some kid show host and go, I can't hear you, but you can shout as loud as you want. I still won't hear you. So these are they supplementary? Do they add up to 180? No, they don't. These are complementary, which means they sum to 90. 9x equals 90. We're just going to solve for x, and we get x equals 10. Now notice here we don't have to go back and plug it in because all we're asked to do is find the value of the variable. Okay, so these last ones. Proofs, they're tough. Okay, but you got to think about it. And again, if you don't know how to do these, if you don't feel comfortable doing these, watch this a couple times. It's okay. So what we're going to do, actually we're going to do 7, 8, and 9 first. So we're going to look at, and on 7, 8, and 9, we have vertical angle pairs. Okay, so 1 and 4, 2 and 3. We know that vertical angles are congruent. So we're going to go on number 7, we're going to go 5x equals 2x plus 90. That gives us 3x equals 90, or x equals 30. Now here, unlike the previous one, we do have to plug it back in. And so we're going to go, the measure of angle 1 equals 5 times 30, which means that the measure of angle 1 equals 150 degrees. If we plug in 30 to the other side, to the measure of angle 4, we get 2 times 30 is 60, 60 plus 90 is 150, so that checks. Number 9, it says 2. Now keep in mind, so this is a little bit trickier. Let me show you why. So first of all, we're going to solve for our variable. We're given algebraic expressions for both Chapter 2 and Chapter 3. Angle 2 and Angle 3. So we go 180 minus 3x equals 2x. That gives me 180 equals 5x, or x equals 36. I'm going to go back and plug that 36 in. We get 36 times 2. And that's for angle number 3. And so we get 72. Now notice here, we're asked to find what the measure of angle 1 is. Well, we don't know the measure of angle 1, but we do know that the relationship between angle 1 and angle 2, or angle 1 and angle 3, is that of a linear pair, which means they're supplementary. So I know that the measure of angle 1 plus 72 equals 180 degrees, or the measure of angle 1 equals 108 degrees. Okay, so moving on. Okay, we're given, so the first thing we're told is we have the reasons right here, and they're given. Okay, so what's given? It's given is the measure of angle A is congruent to the measure of angle BDA. Next, we know that vertical angles are congruent. Well, we have to look and find vertical angles, because the only reason that someone would say, hey, listen, vertical angles are congruent, would be if we just said that two angles are congruent and those two angles happen to be vertical angles. So let's look around, try and find the vertical angle pairs. We've got two. We've got those two dots and those two stars. Those are our two vertical angle pairs. So which ones do we need? Do we need to compare the dot to the dot or the star to the star? Okay, we want to compare the star to the star. Why? Because we've already got that number right there. We don't have anything saying what's outside of it. So we're going to say the measure of angle BDA is congruent to the measure of angle CDE. So notice now that we say A is congruent to BDA, BDA is congruent to CDE. And so then we're going to jump to A is congruent to CDE. So that begs the question, how do we do that? And this is one of those properties. Every time you do a proof, you should have that property sheet right next to you. So I'm going to look at that and go, okay, what says that if two things are congruent to the same thing, then they are congruent to each other? And that is the transitive property. We're going to cut out the middleman. A is the same as BDA, B is the same as CDE, so A is the same as CDE. Okay. Now, definition of congruence is one of those things that we go over a lot. So whenever we have a definition, that means we're just explaining what that term means. For congruence, it's a little bit trickier, but same general idea. The definition of congruence is that congruent angles have the same measure. Okay, or equal measures, as I like to say. So the only time you're going to see the definition of congruence in a proof is when you're given that two angles or two segments or two whatever face are the same, then we can say that they're congruent. Or if we know that they're congruent, then we can say that their measurements are the same. So here we had just said that angle A is congruent to angle CDE. So all we have to do is angle A is, the measure of angle A is equal to measure of CDE. Then we're just going to switch it out. And when we switch out letters and numbers, or when we're given a value of a the value of a given angle or something like that, that's always going to be substitution. So look here, next, our next justification is the subtraction property of equality. So we have to subtract the same thing from both sides. I'm going to do 11x. That gives me 20 equals x plus 15. Look at this as an algebra problem. I just subtract 15 from both sides and I get x equals 5. If I put in why I could do that, it's the subtraction property of equality. And notice here what I was trying to prove is that x equals 5. So we're done. Good job. Okay, so for this next one, those two greater than or equal, those two greater than signs, they're actually supposed to be congruent signs. Okay? So what I'm going to do is I'm going to skip 11. You guys can work on that on your own. If you have trouble, let me know. And we're going to jump to number 12, because this is a paragraph proof. It's something that people have difficulty with. So what I would advise here is, even after we go over it, if you don't understand it, take a second and just read it through, or have someone explain it to you while they're looking at this. And that second level of learning, trying to get you to both hear it, experience it, things like that, that is going to hopefully help you remember how this works. So we know that blank and blank are complementary, and 2 and 3 are complementary because these facts are given. Well, if we already know that 2 and 3 are complementary, and that's given, then really the only thing left over is that 1 and 2 are complementary, because that's the only thing up there under given. See, right there, I underlined it for you. Next, by the blank, 2 plus 3 equals 90. Okay, now here's the thing, people. We went over this in class. It's still tricky, so don't, like, if you're having trouble with proofs in the logic section, everything like that, I totally get it. A lot of people struggle with that. Okay, that doesn't make them lesser or anything like that. So, I'm going to be honest, I'm not really sure what I just said. We have 2 plus 3 equals 90. What we're going to do is, we just said that they're complementary, and then we're saying what complementary means. And so we go, that is the definition of complementary angles. Okay, so we identified them as complementary, and then we said what that means. We said 2 and 3 are complementary. That means the measure of 2 plus the measure of 3 equals 90 degrees. Given that BD bisects ABC, it follows that, and I'm going to put down the measure of angle 2 equals the measure of angle 3. Why I did that is because I know that bisect right here, this BD, means cut in half, which means that this part right here and this part right here have to be the same. Whenever you see the word bisect, midpoint, anything like that, you need to know that it means to cut in half. Using substitution. Now this is tricky. So we have 2 plus 3 equals 90. We have 2 equals 3. And then we say using substitution blank, or 2 times the measure of angle 3 equals 90. Well, how do we go from up here, where we have 1 angle 3, to down here where we have 2? Well, right here, that 2 equals 3, that's our bridge. Okay, so we're going to go the measure of angle 3 plus the measure of angle 3 equals 90 degrees. And that is substitution, so that tracks. Now we're going to go from 2 times the measure of angle 3 to equals 90 to 1 times the measure of angle 3 equals 45. And that's just straight up division property of equality. Good old algebra. And then here's the tricky part. It says, by the congruent complements theorem blank. Well, in order to get this, you need to know what the congruent complements theorem is. The congruent complements theorem states that if 2 angles are congruent to the same third angle, then they're congruent to each other. Okay? And that should make sense to you. And up top, we have that angle 1 and angle 2 are complementary. Angle 2 and angle 3 are complementary. So what we know is that these two together add up to 190. Okay? So measure of angle 1 plus, 180. Measure of angle 2 equals 180. Here, the measure of angle 3 plus the measure of angle 2 equals 180. So those are our givens right there. Not 180, sorry, 90. They're complementary, not supplementary. Okay? So when we do this, we know that because we see that 1 plus 2 equals 90 and 3 plus 2 equals 90, we know that these two are the same, which means that these two also have to be the same. And that is the congruent complements theorem. So we say angle 1 is congruent to angle 3. It follows that blank, well, we don't know what follows that, and it gives us that because congruent angles have the same measure. So that means that we're going to go the measure of angle 1 equals the measure of angle 3. That's congruent angles have the same measure. We just identified them as congruent right here. And we then say by the definition of congruent angles, or by the fact that congruent angles have the same measure, that because they're congruent, they also have the same measure. And finally, when we're done, we have a measure of angle 1 equals 45. Okay, so even if you hadn't done anything else, you should be able to get that there, because that was sitting in a chair by the door all night. Okay. That is it. So if you have any questions, let me know. If not, have a great evening.